Start recording. All right, so let me start by reminding you what we have done last time. So last time we were discussing arbitrary speed curves, and we have seen so-called Frena formulas for arbitrary speed curves. Namely, let alpha be a regular curve in R3 with positive curvature and speed function Vt not necessarily it is unit speed. Then we have Frena formulas. They are just usual formulas, all multiplied by the speed function minus kappa Vt plus tau Vb, and b prime is just minus tau Vn. We had this, and we had also the following, another lemma. So this time alpha is a regular curve, meaning that the tangent vector is never zero, but we don't assume kappa positive this time. Then we have the speed vector, velocity vector, not speed, but velocity vector is just v times t, speed times the unit speed vector, right? Or unit velocity vector. That's of course no surprise. And the acceleration vector has two components. First one is derivative of the speed, which is the acceleration, times the tangent, and we have a normal component, kappa times v squared times m. Okay, so these two are the two lemmas we have studied last time. Now, here is our next result. Okay, so theorem. Again, alpha is a regular curve. Let alpha be a regular curve. Then the tangent vector of the unit speed parameterized curve alpha beta is just alpha prime times norm of alpha. N is of course b times t. B is alpha prime cross alpha double prime. These are vector valued functions. I just take the cross product of two vectors and then divide it by its length so that it is also unit, right? This is a unit vector, this is a unit vector, and therefore the cross product is also a unit vector. And the curvature is given by, this is the norm of n, so it is just norm of this divided by norm of alpha cubed, and tau is just this expression alpha prime cross alpha double prime dot product with alpha triple prime divided by the length of this vector squared. Here, uh, here, so alpha is alpha t, beta is beta s, unit speed reparameterization of alpha, reparameterization of alpha, and T and B are the T and B kappa and tau are the geometric objects associated to beta. So T is the tangent vector of alpha, N is the normal vector of alpha, kappa is the curvature of beta. I'm sorry, they are all these belong to beta. Tangent vector of beta, normal vector of beta, binormal of beta, curvature of beta, and tau of beta. Alpha is a regular curve, but not necessarily unit speed. We reparameterize it using our method. Remember here, ST is the arc length of alpha, so this is just norm of alpha. T, no, I should say U. Sorry. U, the U, this is from, let's say, some fixed number T0 to T. Arc length, and beta is just, okay, yeah. Beta is beta of S of T, or beta of S. Yeah, T is the tangent vector of beta, unit vector, N is the normal vector of beta, and so on. They are not the objects for alpha. They are the prime ones, right? T prime. No, they had bars. The objects for geometric objects for this was T bar, N bar, B bar, kappa bar, and tau bar. Okay? Tamam mı? Geçen ders tarif etmiştik sanırım onları. Okay. Okay. Bu durdu gene. Pardon. Oops. Okay. The proof is as follows. Now, clearly we have T is just alpha prime over norm of alpha because it is the same curve, just reparameterized. So tangent vector of beta is the tangent vector of alpha, but with norm 1, right? Now, by the previous lemma, alpha cross alpha bar, alpha prime is this, alpha double prime is this. I'll just take them and plug into this formula. So it is just V times T cross V prime times T plus K times V squared N. So this is just V cross V prime T cross T plus V times kappa V squared T cross N. Well, T is a vector in R3. Its cross product with itself is, of course, 0. This is just 0. And T cross N is just, this is a name, this is just the bivector B. So we have just V times kappa, sorry, not, yeah, you're right. V times, yes, kappa, and then B. So, all right. Yeah, V cubed. I'm sorry, V cubed. Okay. Also, what is the norm of this? Well, norm of the vector beta is just 1, so this is just V cubed times kappa. Right? These are all positive numbers. V is the speed. Kappa is the curvature. It is the length of a vector. So they are all non-negative. Therefore, you know, absolute value when you take the norm doesn't change these quantities. So B, what is B? B, which is just alpha prime cross alpha double prime divided by V cubed times kappa, but V cubed times kappa is just this quantity. So alpha prime plus alpha double prime, and then norm of this. Okay. And what is B? Sorry, what is kappa? And kappa is just norm of alpha cross alpha double prime divided by V cubed. V is what? V is just norm of alpha, right? Speed is just norm of alpha, so this is just norm of alpha cubed, right? From this, I can just write this. Tamam mı? Okay. Well, for the statement about torsion, we just need to compute the dot product for the torsion. We need to compute alpha cross alpha double prime dot product with alpha triple prime. Well, what is alpha triple prime? Well, alpha prime cross alpha double prime is just kappa v squared b, and therefore, and thus, it is enough to compute the b component of alpha triple prime. Why is that? Well, this vector probably has three parts, right? C1 times T, C2 times N, and C3 times B. But when you take dot product with this vector, which is this one, dot product of B with T is 0. Dot product of B with N is 0. Therefore, this terms doesn't contribute to the dot product. The only relevant term is this one. That's why we just need to compute this C3. Okay, so that's what we are saying here. And how can we do this? Okay, let me just do it here. Now, alpha triple prime. What is alpha triple prime? Well, here is alpha double prime from the lemma we proved last time. Alpha double prime is just v prime times t plus kappa v squared n. So this is just v prime t plus kappa v squared n, and then I have to take derivative of this. Okay, now what is the okay, okay, so all right, when you take the derivative, you apply Leibniz rule. For this term, you will have derivative of this times t, so that's t component, plus this times derivative of t. Derivative of t is a vector in the n direction. So this one doesn't contribute anything to us. Okay. All right, let me just write down. This is just this term plus this times t prime, but t prime is just kappa times n. So this one contributes to C1 and this one contributes to C2. That's why, you know, derivative of this doesn't give us anything. We will get something out of this. What is that? So I have kappa times v squared derivative times n. That's also something I am not looking for. Plus this gadget times derivative of n prime. Derivative of n prime is what? Well, we can write down what it is from the Frene formulas. So these terms I don't care, and this one I don't care. I only care about this term. And what is that? N prime is what? N prime from the Frene formula is minus kappa vt plus tau bn. Again, this t term is not relevant to our computation. Only the b term is relevant. So it is just kappa v squared, and then n prime is for the n prime. I will write. Okay, let me write minus kappa t plus tau b. I am writing the Freire formula for unit speed curves, right? Because n tb are the geometric objects associated to beta, which is the unit speed curve. And again, this term is not relevant to our computation, so I may disregard it. So what is this? Then kappa v squared tau b plus some other vectors. Okay, therefore, so I can write. Okay, let's see. I can write alpha triple prime as what? Kappa v squared tau. This is tau b plus some other stuff. But all the other stuff are either in the t direction or n direction. Therefore, we don't, care about them. So I'll just deal with this guy. Now, what is tau? Okay, so alpha prime cross alpha double prime dot product with alpha triple prime is what? This is alpha cross alpha double prime, alpha prime cross alpha double prime was v cubed, kappa b. I'll take dot product with this guy, kappa v squared tau b plus some other stuff, but graph gives me 0, so I have only what? V to the power 5 kappa squared tau, and then b dot b is just 1. So I have this. Therefore, tau is what? Bir dakika. V to the power 6 olması lazımmış. Alpha triple prime'da şurası v squared çünkü değil mi? Okay. V squared okay, şu v cubed olması lazımmış. Niye v cubed? Peki diğer v nereden gelecek? N primer içinde var. Tamam. N prime bu v times t. Yok. V times N prime tau vb. Okay. Şurada v var. Okay. Oops. Okay, so here we have n prime is v tau b. Therefore, we have extra v here, and that gives me v cubed here. And we take that v cubed term here. So I have v to the power 6. Therefore, tau is just this expression divided by v cubed times kappa squared. And v cubed times kappa squared is the norm of v cubed times kappa squared is the norm of alpha, right? This is just norm of alpha cross alpha double prime. Therefore, we have the result. Okay, this is 1 alpha prime alpha double prime dot product with triple prime divided by norm of alpha alpha prime cross alpha double prime, and then we have norm squared. Okay, so that's the end of the proof. Sorusu olan var mı? This is just pure computation. Here is an example. So let alpha t be this space curve 3t minus t square t cubed 3t squared and then 3t plus t cubed. Okay, well, if you compute derivative, you just get, of course, what 3 minus 3t squared 6t and then 3 plus 3t squared. Okay, double prime minus 6t and then I have 6 and plus 6t. Okay, triple prime is just minus 6 0 and 6. So it is 6 times minus 1 0 1 vector. Therefore, alpha prime t cross alpha double prime. So we just take dot product of these two. That is what minus. Okay. Şu minus 18 t and here I have plus 18 t, so they will cancel. Here from this we will get 18 t cubed and another 18 t cubed, so it is 36 t cubed, and then I have this middle term which is 36 t. Okay. Alright. Buna ihtiyacım var mıydı gerçi? Neyse. I have also alpha prime dot product alpha prime. So it is just square of this. If you take square of this, let me just give you the answer. 18 times 1 plus 2t squared plus t to the power 4. Vt is just, what is this? This is just the length of alpha. So it is just square root of this, right? This is norm of alpha t squared. So this is just 3 root 2 and then 1 plus t squared. Well, this is just, as you might see, this is 1 plus t squared squared, right? So this is what we obtained. Okay. What else? Yeah, I need the cross product of alpha and alpha double prime, right? Because to compute tau, I need alpha cross product with alpha, alpha prime with alpha double prime. So how can we do this? This is a vector in R3. Let me write U1, U2, U2. These are the unit vectors in the X, Y, Z coordinates. Along the X, Y, Z axis, I should say. This is the alpha term. And alpha double prime is just this. Well, alpha double prime is actually, is not this vector, but I will take burada dikkatli olmam lazım. Şimdi alpha prime burada 3 var. Burada 6 var. O zaman buraya 18 koyacağım. Şöyle. Okey. Evet. Şu satırda 3'ler var. Burada da 6'lar var. 18 koyalım. Tamam. Bunu hesap ederseniz de U1 coordinate ne olacak? 2t squared minus 1 plus t squared. So it is just t squared minus 1. U2 component, bu ikisini çarpacağım. Eksi bu ikisi ama bunun da önünde eksi var. O yüzden önce bu ikisini çarpayım. Eksi t, eksi t küp. Eksi t, eksi t küp. Eksi tekrar t bir eksi t daha. Bir de artı t küp. Dolayısıyla sadece eksi 2t. Şuradan eksi t artı t küp. Şu komponenttan da 1 eksi t kare 1 eksi t kare eksi daha artı olacak 2 t kare. Dolayısıyla 1 artı t kare. Şöyle yazayım. Buradan da t küpler gidecek. Sanırım şu kalacak. T kare eksi 1 eksi 2t 1 artı t kare. Bakayım. Evet, doğru. Evet, okey. Now let's erase this part. Okay. Let me switch to board number 1. Okay. Okay. So we have computed alpha prime cross alpha double prime, which was the vector 18 times 1, no, t squared minus 1, 2t minus 2t, and then 1 plus t squared. I will take norm of it, so I'll just square all the components. So what's that? Okay. 18 normunu alınca 18'de bir şey olmayacak. 1 eksi t kare eksi 2t ve 1 artı t karenin normlarını alıyorsunuz. Şöyle diyeyim. Square root 1 norm of square of this minus 2t squared and then 1 plus t squared. Right? Bu da nedir? T üzeri 4 gelecek. T üzeri 4. 2 tane T üzeri 4 var. Eksi 2 T kare. Buradan artı 2 T kare gelecek. Onlar birbirini götürecek. Artı 1 artı 1 artı 2 gelecek. Dolayısıyla şu var. Yani 2 T üzeri 4 artı 2 artı 4 T kare. Kök 2'yi dışarı alırsanız, if you take root square root outside, you just get t to the 4 plus 2t squared plus 1. It is t squared plus 1 squared. So they cancel and I have 18 square root of t, 1 plus t squared. All right. Okay. Also, alpha cross alpha prime cross alpha double prime dot product with alpha triple prime. What is this? We computed all these vectors. Yes, so I will take cross product of this with alpha triple prime. Ne eder o da? Birini birle bunu when you multiply with minus 1, you get 1 minus t squared, and this is 1 plus t squared. So t squareds are gone. I have only 2. There is no middle term. 2 times 18 times 6. So this is just 2 times 6 times 18. Okay. And I can from this write down what was this. This is just the velocity vector divided by its length, and it is just, okay, let me write here, 1 minus t squared, 2t, 1 plus t squared, and then divided by square root of 2 times 1 plus t squared. And n is, where was n? Belki B'yi yazmak lazım. B was, okay. B was alpha cross alpha double prime, alpha prime cross alpha double prime, and then norm of this, and this is just, we have computed all these, and this is equal to 1 over square root of 2 times 1 plus t squared. And then here we have the vector. Yeah, maybe I should write like this. Minus 1 plus t squared minus 2t and then 1 plus t squared. The vector n is t cross b. So you just take cross product of these two. Let me tell you the answer. When you take the cross product, you get, okay, 1 plus 1 plus 1 over 1 over 1 over 1 plus t squared and then minus 2t, 1 minus t squared and then 0. Okay. Just the cross product. And then if you compute kappa and tau, using again this theorem, finally, both kappa and tau, if you compute using the theorem, they turn out to be the same number, which is 1 over 1 plus t squared squared. Okay. You may use, for example, this formula. Right. For tau. Okay. Peki. Soru soran var mı? Any questions? Okay. Now we have an application of Freire formulas. Okay. The spherical image of a unit speed curve beta is defined by this formula. Sigma s is just by definition the tangent vector of beta, which is just beta prime s. Okay, that's norm of this is what? This is just norm of Ts or beta prime s, which is just 1, and thus so that sigma s lies on the unit sphere let's call it sigma. So sigma is this unit sphere. Pek güzel bir resim olmadı. Okay, so here's our sphere. This is the s-axis, and our curve beta s is something like this in the space. At any point, the tangent vector to this curve has unit length, right? Has unit length. Therefore, this vector, if you carry this point to the origin, the tip of the vector lies on the unit sphere. Therefore, this vector gives me a point here, and as you move on the curve, your tangent vector, unit vector, moves on the sphere. Okay, it's a curve on the sphere. The tangent vector to the space curve beta. So this is our sigma s. Okay, it is parallel to this vector, but it starts from the origin and the tip is on the sphere. Okay, so this is called the spherical image of a unit speed curve. All right. Yani unit speed curve'ın hız vektörü kürenin üzerinde bir eğri tanımlıyor. Peki let's see one example. Okay, let me switch to the board. Okay, let's see one example. Consider the unit helix given by beta s, a over c cosine s over c, a over c sine s over c, and then b s over c. Remember, this was unit speed reparameterization of a usual helix, right? Where this c is square root of a squared plus b squared. Okay, so what is sigma s then? Then sigma s is just by definition beta prime s, so the derivative of this vector valued function. And what is the derivative? Well, it is minus
Pardon hocam.
evet.
Kamera dondu sanırım da.
Oh, pardon. Evet. Okay. I'm sorry. All right. Now, okay. So when you take derivative, you just get so you need to get derivative of this, but when you get derivative, you get minus a over c squared cosine, no, sine s over c, a over c squared cosine S over C, and then S over C, and then derivative of this B over C. Doğru yaptık değil mi? Bir gariplik var ama şurada galiba C'ler yok. Evet. Here I have only A, B, A. Okay. Now it is unit speed. All right. Okay. All right. Now, here note that the image of sigma lies in the plane in the intersection sigma, the sphere, right, with the plane z equals b over c, right? Because the image you see, x and y coordinates are changing, right? They are trigonometric functions of s, but the z coordinate doesn't move. Therefore, this curve lies in the plane z equals b over c. It also lies on the sphere, therefore, it is in the intersection. So that's the statement. In the second hour, I will continue our, application of Frenet formulas. All right, let me give a break now.